ठीक है, so let's start. Okay. There are instances on a line where I line is at position AI on the line. You perform the following operations of number of times. Select integer x for each j less than n. If f is this, then just do this or do this. For each line, count the difference and the minimum. Is set the maximum, minimum, maximum, yeah, int n c in n, right? It's just the maximum difference from each element. Int n c in vector int a n for I equals 0 less than n I plus plus c in a of I, right? Answer is equal to, I will initialize by int max. What is the value of a of I? It can be up to 10 to the power. Oh, it's up to 1000 only, right? For int I equal to 0 I less than ni plus plus. For int val is equal to 0. For int j equal to 0, j less than n, j plus plus. Of val is equal to max of value comma absolute value int of absolute value of a of I minus a of j. Answer is equal to min of answer comma value c out. Answer it's 20. क्या लंबा सा इनपुट कौन देता है भाई? I think n square should pass because n is up to 1000. Failed for what? I. Okay. N is up to 1000 now. I is equal to 0. I less than equal to 1000. If I choose this, right? 1 to 1000, right? 1 to 1000, and then just do I minus this, and then it should pass. Slimes on a line. I think they should pass, right? Because AFI is up till 1000. Oof. Wait a minute. What if? If sum of n doesn't exceed 1000, then it's good. Then it's good. Then it's not TID. Yeah, it's passed, right? Absolute cinema. You find yourself with two arrays of positive integers a and b, both of less than. You are to perform the following operation any number of times. Select integer I and swap a of bi. Determine the maximum value of max of a plus summation of bi. Okay, so you can just apply any number of times. You can swap a of I and b of I. What is the maximum value that you can attain? All right. If let's suppose what, because I need the maximum across b of I, right? So what I will do is a of I, b of I, whichever is maximum, I'll update that to b, and Yeah, sure. That is just, it's like go and just update the maximum values to b. That should work because all the values of b you will always take. A of n comma b of n. This should pass. 3 3 18 27. Why it should pass? Because see, uh I will always take the maximum value in b, because if I don't, I won't include the value. But if I take, I will always include that value. I can, even for a, I can have multiple maximum values. If I read the question right, then it has to be simple. But if I read the questions right, just don't tell me ki I read it wrong and made some previous line, right? It should pass. What is my standings now? Oh, it's 1000. Oh, nice. There are people who are, oh, purist and everyone is solving faster than me. This is the easy version of the problem. The difference between the versions that in this version, you must minimize the sum. You can have the version of all the problem. You value of length n which consider non-zero negative integers, but not. So you can take an index I where a of I is greater than 0, and for each index j which is less than this, you will do it set it equal to minus of a of I. This is easy. What is the minimum now? Should be minimum. And what do you need to output? Okay. Okay, so you will do a of j to minus a of j. So it's like you choose a positive element and then behind that multiply all the elements to -1. So I'll do 3. So let's suppose there are n indices and I choose to perform n operations. So what will happen is, if I do first operation and I do second operation after that, so the effect of the first operation would be cancelled, because let's suppose first operation made some elements negative. It will make all the elements negative behind that, but the second operation will again make that all the elements positive and will make the between elements negative. Right. So let's suppose I only have one operation. If I have one operation, the elements, all the elements behind that would be negative, like multiplied by -1. Their signum function will switch, and if I take 3 indices, let's suppose A, B, C, what will happen? We will swap this. Then it will, when we do this, it will swap again, and this will be swapped. This will original, swapped, original, and when we do this, this is swapped, this is original, this is swapped. So it's like you can do possibly n times, right? So what you can do is, okay, so what you will do is, you will try to, okay, so, and what is the hard version? This is the easy version. Minimal maximizes the sum at the end. All right. So what I'm saying is, let's suppose I perform any m arbitrary operations on I1, I2, I3, I4, I5, which means what it will happen is, if I do I4, I5, this will swap, this will remain original, this will swap, and this will remain original. So if I perform बहुत सारे operations, the last operation will decide the, so like for m operations, I of m will decide for I of m minus 1 also, whether its parity would change or not. So what is the, we need to minimize the sum. We need to minimize the value. So which means what we need to do is, we need to, for every positive integer this, so let's suppose for I1 I swap, what will happen is, either we will take this sum, or we will take the, so okay, so let's do this way. Let's assume all the values of positive integers, where are they occurring. For the first set, we can calculate what is the sum. Second set, we can calculate the sum. Third set, fourth set, fifth set, and so on, until the last set we can calculate the sum. Now what we will do is, we know if I flip this one, this will become negative, but I flip this one, this will become negative, but this will become positive, right? If I flip even this one, this will become negative, this will become positive, and this will become negative. If I swap this one, so it's just a positive negative sequence, and all the other sequences are standalone different. So let's calculate all the values, store them in a vector. If I is 0, there are 0 numbers, we can not add any operation. Okay, we will just add at the end. We'll count number of positive integers. If count is 0, then cout 0, return, and if count is this, you will get multiple answers. What you can do is, one value will be this val, which is the current value. Second will be minus this, or what if, why do I want to do negative, and if I'm doing this second one, why do I want to do this positive and this negative? So what I mean is, let's suppose I have calculated all the segment values. For all segment that is positive, these values are positive, what I'll do is, I'll just at the end subtract the negative one. What is the maximum such that, so it's like I can take the segment sums, and let's suppose this is positive, this is negative, this is positive, negative, negative, and positive. This is positive. Last segment, I'll switch this, so this will become negative. Since this becomes negative, now this all changes. So I will just swip that to make it positive again. To make it negative again. So this is done 2 times, which means it's still positive. So I'll swap this one to make this negative, but this will become positive. I will swap this one again to make it negative. So just go till the back. If this is positive, swap this. If this is positive, swap this. ये टेम्परेचर रिड्यूस कर दो, 22 या 21 कर दो, 21 कर दो. So if this is positive, I'll resolve this group. And
21.
Sure, thank you. Okay, so I'll just make segments and I'll try to flip this such a way that I'll try to flip it, positive becomes negative, then if it's odd, this becomes positive, or sure, that is the answer, n a of n, right? I'll have to sequentially do it. And I'll have to always do it from the back. Why from the back? Because the last operation determines what is the value of the previous operation, so it's better to start with the last one first. Answer is going to int max. What I'll do is I'll just set up on count also. I'll make a vector v and I'll make sum. If a of I, and if I is positive, then what I'll do is I'll make every element including I negative, right? If a of I greater than equal to 0, positive, then we dot push back sum, and okay, so sum plus is equal to a of I. I need to add this to the sum first. Add it to the sum. If a of I is positive, which means this sum will become pushed back to this, and then we'll do count plus plus. And if you do count plus plus, and then we'll set sum to 0 again. Else we'll just only do sum. Else we don't do anything, because like if it's less than 0, it won't do anything. So it's greater than 0. We will push back it to the sum, count plus plus, and sum this. And if sum greater than, if sum not equal to 0, even if this is negative, then I'll have to make it positive. Even if it's just not this, we dot push back sum, right? If count equal to 0, cout 0 intel return okay, so I just need to return this empty array as well, cout 0 intel, because if count is 0, then you cannot run this, right? Just print one end of line, a 0 endel, cout into endel return. Else vector int path and vector int ind indexes. I will store this ind dot pushback I. So what I'm doing is okay, why do we even need to store this? We don't even need to store this as well, because if there is no positive integer, we can't even negate this out. There has to be a positive integer, so this is good. It has to be commented out index, and I'll just index put bash this path. Okay, for int I equal to v dot size I plus plus, oh, I greater than equal to 0, I minus minus, I v dot size minus 1 int step is equal to 0. How many steps we have taken till now? If steps mod 2 agar it's odd, which means I have swapped once. So let's suppose, okay, let's suppose it's even. When it's even, so if v of I is greater than 0, then path plus is equal to path dot pushback ind of I, because index of I will have the same size as this. X of I plus 1 and step plus plus. Agar see, this is positive, then I need to minimize this, right? And if step is odd, which means I have to negate this. If v of I is less than 0, path dot pushback ind of I plus 1 and then step plus plus. And for this, how many steps I have taken? See out step endl for int I equal to 0 I less than path dot size I plus plus, see out path of I, just print the path and then see out endl. So it should be 0, 4 and then 1, 4, something like this. I'll just test it once more. Receipt output 0, 0. Why? How 0? Okay. -1, -2. This is 0. And I push back 2. Then it's -1. And I push back 4. Okay. So after this, in second test case, this is made. So this is the oh, what the fuck I did. I just need to do first go from and find the first positive integer, add that will become negative, and apart from that everybody will become positive. So just go and do this. Just add 3, -3, 2, 1. This will become positive. Oh shit, that is not the answer. I got it. What I did wrong. That is not required. I can just do, I will do this, I'll do this, I'll do this. If count is equal to 0, then this. Dot pushback I. In index, I'll just push back the index of all positive elements, and I'll do count plus plus if this is this. Step is 0, right? Path is 0. I will just tell for int I equal to 0, I less than ind dot size I plus plus. Now what I'll do is if ind of I greater than 0, see out. No. And I will do this from ind y greater than 0 है. Oh, 1 second. What if? नहीं यार, it's easy problem यार. Just go from back, check if this is positive, add this to the path, this will become negative. Array, do one thing. If ind what I'll do is 5. I think this was very easy. I did overthinking on this. It has to be just this only. Go from back, check if it's positive. It's positive, then subtract by -1 and then add that value to the path, because all the positive elements will become -1. And then check if there is any negative, add it to positive. Oh, if there is any negative, don't do anything because it's already negative. It will minimize the sum. I have to make it positive. Right. This was very easy. I overthink on this a lot, which means I'll be pretty bad on my ranking. I'll have to make C and D fast. Nah. I took a lot of time in solving this. I need to make C2 even faster. So C2 is like we have to maximize the sum. So now if you want to maximize the sum, what we do is we want to subtract the negative values. And we will do only for this, right? If I greater than 0, then we will do for this. So that is the constraint. Now I need to do subset counting, something of sort of like that. So I think that then now the subsequent counting will work. See, I just need to maximize this and I just need to give this output. So how will I maximize the sum? So if I multiply this by -1, so what means see, there's positive number, there are a lot of negative numbers behind it, then there is positive, then there is negative. So there is positive number, then there are negatives, and negatives. So I can't touch these negatives, and there is positive one. I can't touch this positive either. So in this, I have some subsegments. If I change this, let's suppose value is positive, this is negative, this is negative. So this will become negative, this will become positive, this will become positive. So if it's positive, I'll not take this. I'll just deliberately choose this, because if this becomes positive and it also becomes positive, and this will also become negative, right? Then this is one segment. There are 3 segments, and that's okay. This will be discarded. Now this is positive, this is negative, this is positive. I will not change this. I will change this one though. If this is negative, so this will become positive. Count will become 1. This will become positive, this will become negative. If this is positive, I won't change this either. If this is negative, it was positive. And if this doesn't becomes this, okay. So see how the solution looks like. So there are subsegments. If the sum is negative for this segment, then I'll just flip this to make this positive, which means now each and every value will flip. So I can't do it subsegment wise. So it's like, okay, and n is dipped into 5. It is positive number. You decide to flip it or not. So why will I even flip it? I will flip it just only because before the next positive. So if what will a positive flip do? So a positive flip will flip all positives to negatives and all negatives to positives. Do I only flip once? If I flip multiple times, what will happen? See, after a flip, that particular index becomes negative. So there is no point to do multiple flips, right? I think this is not that hard. There's no point to do multiple flips because each flip will turn that element to negative. So I need to do one flip for if I do a one flip, it will change all the positives to negatives and negatives to positive. So I'll just maintain two arrays, prefix sums array of total positive total positive sum encountered so far and total negative sum encountered so far. If a of I is positive, and I check, okay, the total positive sum encountered so far is less than the total negative sum encountered. If I flip this bit, what it will do is it will make the positive sum equal to negative and negative equal to positive. So the positive sum encountered so far will be greater than the negative sum encountered so far, which will maximize this. Now, this will increase my step by 1. Now I go back and see, okay, till here, if a of I is negative now, because it would have been become positive. अब positive negative बन चुका होगा, negative positive बन चुका होगा. If the total negative sum encountered so far, which was the actual positive, is greater than this. So if it's odd, if it's even, steps are even. If negative is greater than positive, swap step plus plus. Else, if positive is greater than negative, swap s plus plus. I think that should be the answer. L vector and pre1 n comma 0 if it greater than 0, pre1 of 0 is equal to a of 0, else pre2 of 0 is equal to a of 0. For int I equal to 1, I less than n I plus plus, if a of I greater than 0, then pre1 of 0 is equal to pre1 of pre1 of I, what I'm doing, is equal to pre1 of I minus 1, pre2 of I is equal to pre2 of I minus 1, if a of I हाई क्या है ये greater than 0. Oh damn. If a of I is greater than 0, pre1 of I plus is equal to a of I, else pre2 of I plus is equal to a of I. ठीक है, आंसर को छोड़ो, की ज़रूरत नहीं है. काउंट की ज़रूरत है, काउंट विल बी द स्टेप्स. वेक्टर एंड इंडेक्सेस की ज़रूरत है. ठीक है, इफ काउंट इज इक्वल टू 0, ठीक है, इफ ए वेरी ग्रेटर देन 0 तो काउंट प्लस प्लस. इफ काउंट इज इक्वल टू 0, सी और 0 रिटर्न इंडेल इंट पाथ. अब यहाँ पे हम पाथ भरेंगे. Val is this, step is this. Well, I is equal to n minus 1. ठीक है. Now, a of I multiply is equal to val, right? If step mod 2 equal to 0, which means there is जो इनिशियल कॉन्फ़िगरेशन थी वही है. मतलब इफ pre2 if a of I is greater than okay, shouldn't it be just dp? Because I have two choices, right? Either I take, either I not take. For each value, I have two choices. Either I take, either I don't take. I think it should be DP instead of greedy. Is it DP? So why will greedy not work? So if I'm saying it's positive, no, but steps will also increase. If it's positive, don't, just see. What if you make sure this is positive, if I is greater, you check if I is greater than this, and okay, so it's greater than 0 and negative sum is way more greater, but negative sum was still here, was way high, positive sum was way high, here positive sum is way much, and here negative sum is very less, like it's all positive, but then this is high. So you do this, and there is also one positive here. So instead of doing this, you will do from start. So that's why there is one positive integer, two positive integer, three positive integer, and so on. So if it's one positive integer, here somewhat here, I can just choose to flip this. I will choose check whether this satisfies or not. If it does, add this. How will I check? This sum, if it's greater than, okay, okay. Let's suppose this maximum was very high. This is a quite interesting problem, I suppose. Goats was able to solve this. One second. एक light one कैसे हो गई? Now, how will it maximize this sum? Just need to maximize this sum, right? Okay, well, let me just check the D problem as well. Till then, solving C2. C2 is easy. So if I swap one positive, it will always okay. What if I use C1 only, easy one. See, there are positive numbers, a lot of positive numbers, some negative, negative, negative. What if till this positive, I consider this array only, and in this I do this, and I make sure this minimizes the sum, and then I just swap this. If this is positive, if this is positive, I'll leave it alone. Else, I swap this. Else I swap this. That is good. That is a brilliant approach. So my approach is, so let's suppose there are n elements. The n elements out of which k are positive, right? So I can break the array into 1 to k minus 1 is positive number, which means this array a dash will be a new array, and I can use C1, the code that I wrote, to minimize this. Now if I minimize this, then this is always minimized. Then I can take the kth positive number if I minimize this, if all the negative sum plus kth is okay. Well, there's one more problem in this. Even if I minimize till k minus 1th and I've switched the bits through k, what if the kth number exceeds? Or count in both the cases it's this. And so see, देखो लास्ट से आओ, इतना समझ आ गया कि यार यहाँ तक तो ये पॉसिबल नहीं है. करेक्ट. ये तो पॉसिबल नहीं है, इसको तो ऐसे रहने दो. अब ये पॉजिटिव नंबर आया, इससे पिछले पॉजिटिव नंबर पे जाओ, इसको मिनिमाइज कर दो. ठीक है. दिस one thing. दिस इज थोड़ा तो अच्छा क्वेश्चन है ये, थोड़ा यहाँ तो मैं नहीं सोच पा रहा. 2500 इज बेकार रैंक भाई. आई थिंक इसका सोल्यूशन, दिस इज द सोल्यूशन कि इट्स हैज टू बी समथिंग लाइक कि गो फ्रॉम बैक. I think you can build it up on this. Okay, till this is minimum. Now I swap this. This become maximum. All the negative elements here change, and this becomes negative. So this minimum plus this swaps this. But let's suppose this minimum plus this negative still is less than in the absolute value in terms of this positive number. So if I minimize negate this, so the sum will minimize, not maximize. Okay. Start from first. If there exists any arbitrary sequence K, I know those values will start. So if there is something, there is existing arbitrary sequence K, so it will always start from, I will always start to fill from back. Right. So let's suppose I decide to switch this positive number. That's the only case when the previous positive here alright, now this will become negative. So what I can do is, for a number, till a number, I can make all the numbers positive. All the numbers negative, I suppose. I mean. This all will become negative. Till this positive. That is one case. I can make all of this negative until this positive, and one more. I can make this negative, all the other elements positive. If I'm going to make, this is the only case, right? And so it's like I can make this all elements positive, only this element negative, and this all the behind elements will be negative only. Or I can do the same for each positive number. Positive. So let's suppose there are n positive numbers, I can make for I k till ik all the values positive, then I can make ik minus 1 negative. And do I need to check for all values then? That is the concern. Do I need to check for all values then? So I just need to check for till which index we need to subtract this value. So if I apply an operation on like the last element of k, the last positive element will become -1, and all the positive elements before that can be made +1. So what is the last element that I choose? So it's just either you choose the last, second last, third last, fourth last, fifth last, and so on. And that is the answer, I think. So there are m positive elements or k positive elements. Then you can make till, if you choose the last element of a subsequence, like this, suppose you make a subsequence of m moves, you can make all the elements till the mth positive number negative, and then a positive, and then m can be negative. M will be negative. Then m will be negative. But in that, if you are applying operation, you are making out negative only. So you are doing this only. So I will just move prefix of this. So a of 0, I will just do prefix of 0, and I will do vector int suf n comma 0. Pre of 0 is equal to absolute of a of 0. Absolute value of a of I. And moreover, suf of n minus 1 is equal to a of n minus 1, and for int I equal to n minus 2, I greater than equal to 0, I minus minus, suf of I is equal to suf of I plus 1, and suf of I plus is equal to a of I. Right, now I just need to check what is the right. Count plus plus. Count plus plus, and then I just do this. Right, if count equal to 0, count is equal to n, see out 0, because if it's n, you need not do anything. And if a count is n minus 1, if this is negative now, what I will do is I can choose any positive number, turn it to negative, and turn all the numbers here positive. That is what I'll do. Count is 0, path is this, right? Now, for int I equal to 0, I less than ni plus plus, if a of I is greater than 0, int val is equal to 0, int ind is equal to 0. Alright, path भी हम populate करेंगे. Val is equal to max of value comma pre of I plus suf of I and suf of I by minus 2 times minus 3 times a of I. Right, and f val is equal to this. Okay, so prefix of I plus suffix of I, this will be 2 times this minus 3 times of I. If f val is greater than val is equal to f val, and ind is equal to I. I'll just go ahead with this. Then I'll find the index of that positive number. Okay, अब मेरे को change करना ही है, so there will be some last positive integer that I'll change, and I'll set this. Now, still index, right? Int val is equal to 1. Int multiply is 1. For int I is equal to ind, I is equal to 0. If a of I greater than 0, oh, let's suppose there are multiple positive integers. I need to stop the path now. 0 0 2 1 3 1 1. 6 5 4 3 1 7. N in n EFI prefix suffix absolute of 0. Count is 0 0 0 count plus plus. If count is equal to 0, count is equal to n. C out 0 and l. Vector in path int is 0. Yeah, this will work. I think I could only think of the solution. I think it should not give pretest. One पे तो wrong नहीं देना चाहिए. Wrong होता है pretest 2. I think it's थोड़ा सा tricky तो है ये question. Okay. Why is this not working? एक second. See, one thing here it is. In this, I am always saying first of all, val has not to be 0, it has to be a long min, because that can be the minimum value as well. The minimum value can be, let's suppose it's very less, very negative value, and you just flipped one coin. So this can be done, but there can also be one value where no one needs to be flipped. Okay, let's suppose all negatives, there's 1 0, all negatives, there's 1 0, there's all negatives. If this current positive, this one and is -1. All right. So in this case I was always taking a consideration कि this can be such that कि यार ये always I have to take this. So this is the baseline value of summation of all the values, and if this is greater than 0 I'll have to run this again, right? Okay, see, what I've done is I have set the baseline value to be the summation of all the values. If there is no value that is greater than this, which means IND will always be that value. Skip this. Which means in that case you don't need to take any value. That would be a base case I'm missing. Key, okay, if there is no value that needs to be flipped, okay, there can be one value that needs to be flipped, right? If you flip this, don't do this, just flip this. Yeah, because if there is one value, I'm flipping that value to pakka pakka se. Let's see यार क्या होता है. Might be wrong. I need to set the baseline value to this. If I don't want to swap, this can be wrong. Come on भाई, how can it be wrong भाई? मैंने लिखा है भैंस की आँख. How can it be wrong? Yeah. Problem D is also cool. Theorist could solve it in this much time. Let's try problem D. Oof. Pretty bad rank, but ठीक है, चलो. You are given two arrays of positive integers a and b, both of length n. All right. You will perform the following operation exactly n-1 times. Let m be the current length of a and b. Oh, Teja was able to make it. Okay, Teja was not able to make it. Goats was able to make it. Okay, you are given two positive integers a and two arrays of positive. You are given 1 second. Record हो रहा है ना? You are given two arrays of positive integers a and b, both of length n. You will perform the following operation exactly n-1 times. Okay, let m be the current length of a and b. Note that length will always be equal. All right, select an integer. Okay, so select any index. Let s be the, okay, you can't select the last index though, but okay. Let s be the multiset a. Okay, just if select any index, these two elements, and bk these two elements will form a belong to multiset S. Sort the elements of S. All right. Now replace ai plus 1 with S2, bi plus 1 with S3. More formally, replace a with all good and b with this. After performing all operations, there will be exactly one element remaining in both a and b. Okay, so what you are doing is, so you take two elements from A, two elements from B, you sort them, you take, thus out of those four, you take the second and third max element, and then the second max you append to A, the third max you append to B, and you want to do these. Why? Okay, so we want to minimize the value of A1, B1, right? So which means we want to minimize, so we can also consider it as this ways. So we have NA elements and NB elements. We can, instead of considering them different arrays, we can do A1, B1, A2, B2, A3, B3, and so on, AN, BN. So this is an array of 2n elements. Now, if I choose any index I, like from A, like 0 to 4, any even index, so which means I am choosing A3, B3 and A4, B4. So I am choosing 4 consecutive elements from this array of this array of 2n elements and then sorting them and just putting in back the two different elements, and that is the answer. So so I can tell what I'm doing is, see, so there are some observations that I'm making on this observations, right? Don't consider both arrays separately. See, what if, let's suppose A is an array from A1, and then you have A2, then you have A3, and so on till AN. Similarly, you have B1, B2, B3, and so on till Bn. Right? In one operation, you choose AI. Like I will make an array of length 2n elements. Why I'm doing so? It will look like this: A1, B1, A2, B2, A3, B3, and I'll tell you how will this make my problem very simple. And the last two elements will be AN, Bn. So why this makes my problem very simple is, if I choose any two elements, like I was choosing here AI, I was choosing AI, I plus 1, I was choosing BI, B I plus 1, right? So in this way I will be choosing just 4 elements from this, which means like this only, like you don't need to choose from two separate arrays, you will be choosing. So the problem boils down to, in this array, in this new array, I need to take substring, I need to take substrings of length 4, then sort them and reduce them to length 2 and add back to the array, and this has made my problem way simpler. So it's just like you have 4 elements उठाने. Now what would be the logic if I go about and what I need to do is I need to minimize this. So अब ऐसे ऑपरेशन में क्या होगा, -2 एलिमेंट्स होते जा रहे हैं हर ऑपरेशन में, एंड सो ऑन एंड 2n -2 elements 2n. So at the end there will be 4 elements remaining. Then last 4 elements पे this operation will be performed, and then this 2 elements will be remaining, and these two में से जो minimum है that has to be maximized. Alright, so which means I need to, in this array, new array, I just need to, it's simple, you just need to remove the, for each substring you need to remove the minimum element and the maximum element. You will be left with the two between elements, and you need to do this operation as many times you can. No, not as many times, n-1 times you will be able to do, and in the last operation you will be getting 4 elements and you will be resolving them to 2 last elements. Okay, now let's make some more observations on this. Teja was able to make this now, so this is not that hard. Okay, and what? So, okay, and if I choose any 4 elements, so it's like मैं उनके बाहर के elements remove कर रहा हूँ, then नए 2 elements आ रहे हैं, अब उनको remove करेंगे तो 2 बचेंगे बीच के, min max दोबारा हटेंगे. So if I perform these operations optimally n-1 times, so I will remove n-1 maximums of n-1 maximums. Not, I will not be removing the maximum, I'll remove क्या बोलते हैं उसको, local maximas, local maxima and local minima. So it's like you have बहुत सारे elements and in one operation of these 4 elements you are removing the local maxima and minima. Okay, so this is the problem. Okay, so I need to minimize the maximums, right? I need to maximize the minimums, sorry. So I just need to remove all minimum elements that I can get as fast as I can. So let's suppose there are minimum elements, no? So also we will process in batches. So like first batch hoga 0 to third index, both inclusive, 0, 3. Then next batch will be of 4, 7, 4, 7 inclusive. The next batch will be of 8, 11. Or there can be intermediate batches as well of like 2, 5, 2, 3, 4, 5, and so on. So let's suppose I choose 2, 5. I remove some 2 elements. Then what will happen is, now I will include the first element. I remove these 2 elements. So it's like this. So I say 0, 1, 2, 3, 4, 5. ये थे तो हमने, and there were 6 and there were 7. There were 8 elements. So I took 2, 3, 4, 5. Then I got these 2 removed. Now I can take this element. I now have again have 1 choice, 2 choice, 3 choices. Let's suppose these are the only elements. I need to maximize this. So what I will do is कि मैं ना minimum को maximize करना है. So I will just remove this first. All right. Can't I just do binary search? Oh, and what is the order of range of elements of n? A of I, B of I are up to 2n. Can't I do binary search? Okay. See, if I can make mid to be the maximum value of the minimums, then I can make all values. No, I can't make all values because I'm also removing the minimum also, no? In each step. I'm not just taking out the maximums. I'm removing minimums as well. So for sure, I will remove n minus 1 minimums. This is for sure. I will remove n minus 1 minimums. Okay, let's not take the positive numbers in consideration for like the maximum numbers. In each operation, you are removing the minimum element. So you will end up removing n minus 1 minimums like this only. So and can these n minus 1 minimums will depend on indexes. Let's suppose the first minimum is with a1, b1, a2, there are 4 elements. This is the first minimum. This lies somewhere, anywhere, like somewhere in this. It will always be removed. So you will remove n minus 1 minimum. So these values can't be answered. So like if it's 1, 2, then 1 is the answer because there is no operation you can make. Is 245136. Arey yaar, light. 245136. Hmm. Hmm. 245136, right? So it can be 214356. This is the array. Now I can remove one. I will make two operations. Right? I can remove one. I can remove two. When I remove one, I will remove three. I will remove four as well, and I will be removing five as well. So 3 and 6 will be remaining. So second answer will be 3. Third में 7 4 5 6 4 7 8 8. I'll remove. I'll do 3 times, right? 3 operations. So I'll remove this 4. I'll remove this 4. I'll remove this 5. So when I remove the first element, I have two options here in this case. Whereas I have multiple options, I have 3 options. I will have multiple options too because there can be 4 indices where this minimum element can lie. I will end up removing 7 4. Then I'll take this one. I'll end up removing 4 8. Then I'll take 7 4 is done. 4 8 is gone. I'll take this one and I'll remove 5 and 8. 6 and 7 will remain, so 6 will be the answer. So it's like last n minus 1 elements can't be there. But the just bigger element than that will be there. These people were able to make it, right? This is not that hard, I suppose. I need to solve this. So it's like mark all the minimums because n minus 1 minimums because you will be removing those. Or else what you can do is, because we know only 2 elements will remain. Let's forget about the 2 elements. Just see what minimum element will remain. Let's suppose this is the array 2 2 2 2 4. Now 3 elements will be remaining. Removing 1 this, 2 this. It's some sort of क्या segment tree variation क्या कुछ. What else can, so this is the one of the most basic implementation. Is this some sort of segment tree variation? Key segment tree variation, is it there segment tree variation on this, or is it a DP variation? What is n? N is 10 to the power 5. Is it some sort of DP variation? Okay, let me see. DP. Let's think from DP angle now. All right. So if I end up removing for ith position, so I will remove I plus 1, I plus 2, I plus 3. These 4 elements I will remove. Then dp of I will go directly to dp of I minus 4, comma dp of I plus 4 min of this. No, because we are moving 2 elements, I minus 2, I plus 2, and so the dp angle is ignored. No, there is no dp angle in this, because dp of I depends on I minus 1 as well, and dp of I depends on I plus 2 as well. So it's like it's dependent on both sides. So there is no base case that can be formed. So like dp of I is dependent on both the forward and the negative, on the backward states. Or so I will have to make some observations only. So n minus 1 minimums will be removed. That is one observation. Will be removed. Okay, now what? Can I do something like this? Can I mark this element? Mark some element, and I say can this be removed? Can this not be removed? But even if I mark an element and I say this cannot be removed, what about the second element, next element? Can't we also say something similar? Okay, we are taking 4 elements and we are making a very good choice. See, we are making a good choice here. So I think this observation is good that I made, but there should be something more. There has to be some or more observations on this. क्या मैं that method try करूँगा कि n-1 minimums remove हो. अब मैंने एक बार ना सारे minimums mark कर दिए. एक काम करो, 2n साइज का एरे है, सारे n-1 मिनिमम्स मार्क कर लो। मैं सारे n-1 मिनिमम्स मार्क कर लेता हूँ पहले। जो उनमें आते हैं इनके। Right, I will just mark all the n-1 minimums and then I will remove n-2 elements ना। So जो फर्स्ट मार्क्ड है और जो लास्ट मार्क्ड है उनके बीच में I will check number of elements। और जब तक वो लेंथ n-2 से बड़ी नहीं होती या n-2 के बराबर नहीं होती, सी तेरा n-1 एलिमेंट, ठीक है, मिनिमम्स। अगर चलो लेट्स सपोज वो लेंथ n-2 n-2 के बराबर है, पूरी बहुत बढ़िया है। या तो 2n होगी, या तो 2n-1 होगी, या तो 2n-2 होगी। अब मान लो ये और ये 2n-2 है। सो व्हाट आई कैन डू इज, इसके अंदर तो सब हटेगा, इसके अंदर कुछ कुछ होगा, ये सब एलिमेंट्स बचेंगे। ये दोनों एलिमेंट्स तो हमेशा बचे रहेंगे कि इनको भाई बचा के रखो। इसके अंदर दैट देयर इज वन मोर ऑब्जर्वेशन दैट आई मेड कि अगर मैं कोई एल और आर रेंज को रिमूव कर रहा हूँ, कितनी भी ऑपरेशंस करूँ इस एल आर रेंज के अंदर, तो मेरे पास हमेशा रेंज का मिन और मैक्स एलिमेंट बचेगा। मतलब एक एल आर रेंज के अंदर अगर मैं सारे ऑपरेशंस लगा दूँ, सो इस रेंज का मिनिमम और इस रेंज का मैक्सिमम एलिमेंट हमेशा बचेगा मेरे पास। सो आई कैन डू वन थिंग, सी मेरे पास एल और आर एक रेंज है, इसका मिनिमम तो नहीं, मतलब हमेशा हटेगा। ये हटा, ये हटा, ये हटा, ये हटा, मतलब एल आर मिनिमम में हटेगा, मतलब बीच के एलिमेंट दो बचेंगे। एलएम बचेंगे। तो अगर मैं कोई भी रेंज लूँ ऑफ 2n+2 साइज की, ऑफ कोई भी 2n साइज की, तो उसके बीच के दो एलिमेंट्स बचेंगे। सो आई टेक दिस टू रेंज। सो व्हाट इज दिस इज कि अब तुम बहुत सारे सेगमेंट्स में ब्रेक करते हो ऑफ इवन साइजेस। सो इट्स लाइक कि अगर मेरे पास कोई इवन बहुत सारे सेगमेंट्स हैं, लेट सपोज मैं पूरे 2n साइज के आरे को ऐसा ब्रेक करता हूँ L1 comma R1 and to L2 comma R2. I will break them into two segments, only two of even sizes. अगर जैसे है, अगर लेट्स सपोज इवन नहीं है, लेट्स सपोज 6 है, जैसे 6 साइज के हो सकते हैं, तो एक ही बनेगा ना. अगर इफ आई एम एबल टू ब्रेक इनटू दीज टू सेगमेंट्स, तो मैं क्या करूँगा, दोनों के बीच के बचेंगे, तो मिनिमम, तो मैं कोई भी दो सेगमेंट में ब्रेक करूँगा ऑफ इवन लेंथ, उनके कोई तो दो बीच एलिमेंट्स बचेंगे. देखो मैंने पहला 2 साइज का बनाया, अगला ओह दैट इज द सोल्यूशन. क्या अगर मैं दो एलिमेंट इधर से निकाल सकता हूँ, दो एलिमेंट इधर के, दो एलिमेंट इधर के, और दो ऐसा करो, दो एलिमेंट इधर के. मल्टीपल सेगमेंट्स का फायदा नहीं है, तो इन दोनों के एक एलिमेंट रिमूव कर रहा हूँ, और फिर जब इन दोनों कंपेयर कर रहा हूँ तो इन दोनों के एक रिमूव कर रहा हूँ. सो इट्स लाइक कि इनको ऐसे अलग ऑपरेशन कंसिडर मत करो, कंसिडर देम एज सब सीक्वेंसेस. राइट, कंसिडर देम एज सब सीक्वेंसेस, कि यार ये सब सीक्वेंस इज देयर प्रेजेंट इन दिस. सो if there is a very big subsequence that I'm arranging, which means उसके दो एलिमेंट्स बीच के बचेंगे मेरे पास, right? So it's way too simple now. क्या go through will I always take the uh, middle two elements? Will it always work? Will I always take the middle two elements? And will it always work? Or what I can do? By 1500 people made this. Either they are using Gemini or I am low skilled bhai. The people in Rubrik are not able to solve this fast, but I need to make D pretty fast. Okay, so if I'm taking all the minimum ones or the middle ones, then I'm taking the median ones, no? Hmm. और कोई ऑब्जर्वेशन इसमें कैन आई मेक? Is there any segment tree variation जिसमें मैं इसको solve कर सकता हूँ using segment trees? Okay, for these two elements. Okay. Wait. Let's create a segment tree. Segment tree में क्या होगा? See, this is the node. This will contain two elements, A, B. अब ये दो नोड्स पे जाएगी, लेफ्ट चाइल्ड एंड राइट चाइल्ड. जो लेफ्ट चाइल्ड होगा है और एक होगा इसका राइट चाइल्ड. राइट, जो लेफ्ट चाइल्ड होगा वो प्रीवियस दो एलिमेंट्स देगा लेफ्ट साइड से. लाइक A1, B1, और ये दो एलिमेंट देगा इस साइड से A2, B2. और रूट फंक्शन क्या होगा सेगमेंट ट्री का? इट विल बी, you will get 4 elements, you can just sort them and then return A1, A2, like the first, second and third element. So which means, and there will be two cases. क्या अगर 6 एलिमेंट है ना, तो एक बार इसका बनाओ और इसका बनाओ. जैसे तो इसने 2, 3 रिटर्न किया, इसने 4, 5 रिटर्न किया, तुमने 3, 4 बना के रख दिया. So if the child array length is array length is a power of 2, then break it into 2 powers. Powers. Else let's suppose 12 होता. ऐसे नहीं होगा. तुम 2 के सारे पेयर बनाओगे. तुमने सारे बना दिए. तुम इन दोनों को रेस करोगे, इन दोनों को रेस करोगे, इन दोनों को रेस करोगे. 2 का एक पेयर बनेगा, 2 का एक पेयर बनेगा, 2 का एक पेयर बनेगा. इन दोनों को रेस करोगे, 2 का एक पेयर बनेगा. इन दोनों को रेस करोगे, 2 का एक पेयर बनेगा. इन दोनों को रेस करोगे, इन दोनों को रेस करोगे, 2 का एक पेयर बनेगा. दैट इज़ वन केस. बट सेकेंड केस इज कि तुमने इसको रेस किया, इन दोनों को रेस किया. सो इसमें देखो, अब इन दोनों केस में अगर आंसर डिफरेंट आ रहा है तो मेन माई अप्रोच इज रॉन्ग, बट इफ माई आंसर सेम आ रहा है तो माई अप्रोच इज करेक्ट. सो इसमें ये और ये एलिमेंट आ रहे हैं. जो ये आ रहा है ये तो हट जा रहा है. I think this is a segmentary variation. Now I'm confirmed with this. But I'm just thinking how to apply segmentary on this. So मेरा segmentary का logic is good. Okay. Two elements. Okay, break the array into two elements. Take max up. Then ऐड देम टू 4 2 2 2 3 एलिमेंट ये है ना, इन दोनों को मिला के 2 एलिमेंट का ग्रुप बनाओ और इसको ऐड करके डायरेक्ट ऐड कर दो, या फिर इन दोनों को डायरेक्ट यूज़ करो, इन दोनों का एक ग्रुप बनाओ और इसको ऐसे ऐड कर दो। 2 वेज हैं, ठीक है। अब जो 2 वेज हैं, इन दोनों से 2 डिफरेंट आंसर्स आएंगे। और सो फॉर n इज इक्वल टू 3 में 2 वेज हैं n इज इक्वल टू 4, एक ये वे है जिससे एक फाइनल आंसर आएगा, इसमें भी 2 वेज हैं, इसमें 3 वेज हैं। सो n इज इक्वल टू 3 में 2 वेज हैं, एक ये 4 में एक ये वे है, इसमें भी 2 वेज हैं। ओके, सो दिस इज थोड़ा सा ट्रिकी है ये क्वेश्चन। 4 में क्या वेज है? ओके, जो ये 1700 लोग बना रहे हैं इसको, भाई कैसे बना रहे हैं भाई, इतना प्यारा क्वेश्चन है यार। आई नीड टू मेक पर ई देखें क्या है, ओ लोड अनबैलेंसिंग, वो एफ क्यू खोल दिया, ई a tree with a node from the sky along with an initial empty set is यार डी ही सॉल्व करना है, बट व्हाई आई एम थिंकिंग इज कि हाउ टू वी सॉल्व दिस। यार this has to be something of this only, but एक सेकेंड, अगर मैं फर्स्ट लास्ट को रहने दूँ, should I just say this thing कि 4 cases are there. First element, then you make a array of these elements, or first 2 elements and then you make sub array of all the elements, or sub array of this and then last 2 elements, and or array of all the elements, which may okay, can we do something like this? इसको मतलब ये है कि मैं फर्स्ट लास्ट एलिमेंट को इग्नोर कर सकता हूँ, बट सच दैट अगर मान लो 4 एलिमेंट है, तो मैं 2 निकाल लूँगा, इसके 2 मीडियन, ठीक है। एक बार चेक करते हैं, एन बी एन ए एन ना, मेरे को लगता है हो सकता है, सोच तो मैंने बहुत ज़्यादा ही आगे कर लिया, बट मेरे को लग नहीं रहा इतना सारा ओवर थिंकिंग इसकी कैप रिक्वायर्ड है इस क्वेश्चन के लिए। वाई आई एम कॉन्फिडेंट इन दिस अप्रोचेस कि यार सी मतलब देयर इज नो अदर केस वेयर आई कैन एक्सक्लूड 2 एलिमेंट्स। सी 4 एलिमेंट्स मेरे पास आखिरी में बचेंगे, उनमें से मैं 2 एलिमेंट्स में चॉइस बना सकता हूँ कि मुझे कौन से 2 एलिमेंट्स चाहिए, बाकी 2 में मैं चॉइस नहीं बना सकता क्योंकि फर्स्ट लास्ट रिमूव हो रहा है। सो वो जो 2 एलिमेंट्स है, ऐसा नहीं होगा कि 4 में से 2 एलिमेंट, देखो 2 एलिमेंट है जो हम स्टोर करके रख सकते हैं कहीं पर भी। अब वो बीच में हो सकते हैं कि नहीं, वो बीच में नहीं हो सकते। लेट्स सपोज 2 एलिमेंट बीच में भी हो गए, आई कैन टेक 2 एलिमेंट्स, इसके इर्द गिर्द के जा, इधर से भी कुछ आएगा, बीच में से भी कुछ आएगा। लेट्स सपोज 2 एलिमेंट्स बीच में कहीं होते हैं, ये हो सकता है क्या केस? पहला एक रुको, पहला एक यार, पहला एक सब एरे है, दूसरा एक सब एरे है, एक बीच का एलिमेंट है, तीसरा सब एरे है, एक बीच का एलिमेंट है, चौथा सब एरे है, ऐसा सो ऑन, और एक और सब। अब ठीक है, बस यही है। अब मैंने इनको सेलेक्ट करा तो इसमें क्या होगा, हाँ इसमें क्या होगा कि यहाँ से 2 आएंगे, फिर यहाँ से एक आएगा, फिर यहाँ से 2 आएंगे, फिर यहाँ से एक आएगा, फिर यहाँ से 2 आएंगे। अब मैंने इसको फिक्स कर रखा है, विच मीन्स आई विल हैव टू यूज दिस फॉर दिस सब एरे, और आई विल हैव टू यूज दिस but I can only make choices if the elements are corner elements. C push back A of I, C dot push back B of I. ठीक है, अब I will make case 1, vector int C1, vector int C2, case 4, case 4 में तो कुछ भी नहीं है, for int I equal to 0, C4 is equal to C3, is equal to C, case 3 is equal to C, बीच के दो है ना, C1 में हमने 1 से n - 1 की सारे डाल दिया, C2 में हमने वो कर दिया 2 से n सारे डाल दिए, C3 हमने C के बराबर रखा है, बट C3 डॉट पॉप बैक 2 बार करना है। C3 डॉट पॉप बैक, अब सब बन गए ना, अब ASC C1 C2 C4, केस 1 ना। अब केस 1 क्या है, C of 0 A1 dot PB C of n - 1। ओके, रुक जाओ, if n is less than equal to 2, now अब case 1 case 2 है, A1 is this 4 है ना, 2 A1 dot pushback C1 of mid A1 dot pushback C1 of mid -1, right, ASC A1 असेंडिंग ऑर्डर में A1 को डालेंगे, val is equal to min max of val comma A1 of 1, clear। यार वेक्टर इंट A2 बना लेता ना सीधा यहाँ पे, वेक्टर इंट A2। अब A2 में क्या है, A2 dot PB C of 0 A2 dot PB C of 1 A2 dot PB C2 of mid A2 dot PB C2 of mid minus 1. ASC A2 val is equal to max of val comma A2 of 1, right? And similarly I have to do A3 as well. A3 में लास्ट के दो एलिमेंट रिमूव हुए हैं ना. A3 में n-1 करना है, यहाँ पे n-2 करना है, C3 ऑफ मिड करना है, C3 ऑफ मिड -1 करना है, C3 करना, A3 करना है, इधर भी A3 करना है, इधर भी 4 करना है, A4 ये हो गया. और C4 सी आउट वैल एंड डेल. अब पता नहीं चलेगा कि नहीं, मेरे को लगता तो चल जाना चाहिए. वैसे मेरे को लगता है रॉन्ग भी है ये. दिस इज सम सेगमेंटरी प्रॉब्लम जो आई एम नॉट एबल टू अंडरस्टैंड आई सपोज. सेगमेंटरी बाइनरी सर्च तो मुश्किल लग रहा है, बट सेगमेंटरी लग रहा है मेरे को इसका मोस्ट प्रोबेबली. What can be the answer for this? I'm just replacing it with the medians. Right, I'm replacing it with medians always. I think it's D9, it's not that easy. Eknerwala solved it. अरे यार, टॉप स्टैंडिंग्स पे जाते हैं, देखते हैं कौन कौन है. Bro, how come Tuer is just so down? So it's like you sequentially process them, not like कि ऐसे ही कुछ भी process करोगे. There is a sequence in which I need to process these elements. Hmm. I think I'll stop this. I'll go for dinner then. Bye bye. This is still here only.